So dear students, so far you have seen some important points of the second chapter, and they are about the elements and metals and non-metals. So you have learned about these three. Now today I'm going to explain another point. It is mixture. Mixture is other form of matter. It can be natural, it can be man-made, and it is see how. So children, mixture is actually, as name indicates, it is a substance. It is a substance made up of two or more components, several components. There can be many more components, tens of components, and they don't have any ratio as such. They don't have any ratio as such. So see how it is. It is a type of matter. Type of matter. It is form of matter because it has mass, it has volume. It is type of mixture made up of two or more components. The components can be two or more. Component means from which it has been made. Two or more components present in any ratio. Any ratio, children, any ratio means the composition is not fixed. Their composition is not fixed. Mixtures can be of different type. Not like that of namkeens of different variety. It is also called mixture, but it is there. It can be because we go to any shop who sells this snacks. We can customize as per our requirement. We add more peanuts, more gram, and so it is not fixed. Different companies, they sell at different, so it is also mixture. It is just right. Now examples are air, tea, coffee, soil, etc. Many more substances available around us. They are mixture. Now the classification or types of mixture. Children, as you know, the mixtures are of two types. First is homogeneous. And second is heterogeneous. It is of two types, homogeneous and heterogeneous mixture. So homo, the word homo means same. Homo. Here we write homo means same. Hetero means different. So mixture is said to be homogeneous when we cannot distinguish between the components by naked eye. So a mixture in which we cannot differentiate between the different components by our eyes. We cannot differentiate. For example, air. Air is made up of different components. Air is made up of oxygen, air is made up of hydrogen. It has dust particles, it has several gases, water vapors. And so, can we say by naked eyes? No. We cannot identify, we cannot say this is CO2 molecule, this is water molecule, this is sand particle, this is like that. So this is the about the homogeneous mixture. We are unable to differentiate between the different components by the naked eyes, by the open eyes. So it is said to be homogeneous mixture. And again, example here, tea, coffee, etc. No, they are homogeneous mixtures. We cannot differentiate that this is milk particle, this is uh, sugar, this is water, and whatever it is. So this is homogeneous. Now coming to heterogeneous. So in case of heterogeneous mixture, again the same, that a mixture in which we can easily differentiate different components by eyes or naked eyes. We can easily, so mixture in which we can easily differentiate different components by eyes or naked eyes. Like we have mixture, say soil. We cannot judge soil completely, but we are able to say that this is pebble, this is sand, this is gravel. Soil has different compositions, so we can see. So example, soil is there, then mixture of sand and salt, mixture of sand and sugar, etc. They are heterogeneous mixture. We cannot. Other example, children, you can know fruit juices. They are homogeneous. Lassi, homogeneous. We cannot differentiate between the components by naked eyes. Now, further, they are of different types. Now, homogeneous mixture, children, and homogeneous mixture here, it is first true solution. True solution. True means which is real. True solution means a solution in which the particles forms a homogeneous mixture and particles are not seen by the naked eyes. So a solution in which the particles cannot be seen by naked eyes or eyes. Naked eyes means open eyes without the help of any microscope, without any instrument. So example like salt solution, sugar solution, and many more. We cannot differentiate that this is salt, this is sugar, etc. Now coming to heterogeneous mixture, children. So heterogeneous mixtures, again, it is of different types. So first here I am going to mark so as to separate. So this is one true solution. Now second, it is colloidal. Colloidal solution. So this is new for you, colloidal. And the third one is suspension. We'll see about them in detail in next topic. So colloidal solution. Colloidal, it is new type of solution, and it is it is actually heterogeneous in nature. and the particles are having different properties. Particles are having rather astonishing properties. Examples are milk, blood, fog, mist, paint, nail paint, ice cream. They are a special type of solution. Actually, colloidal solutions are a special type of solutions, and they are heterogeneous, but they appear to be uniform. They appear to be uniform. So here they have some special character and are highly stable. They are highly stable. Milk, fruit juices, buttermilk. You keep as it is for several hours. You keep milk in refrigerator. Milk will remain as it is. That the components of milk, that is water and the milk protein, will never going to settle down in the bottom. We purchase, milk in the packets. What we see? The particles, they remain as it is. We cannot differentiate. So milk, example, we have milk, fruit juice, etc. They are colloidal solutions. We'll see in detail in later part. Now coming to suspension. So suspension, like mixture of sand and water, mixture of soil and water, mixture of chalk and water. What you see? The particles, they settle down in the bottom. Particles settle down in the bottom easily. It means they are not stable. Means they are highly unstable. Example, soil and water. They are suspension. Now see how? Now if you take the case of colloidal, so colloidal solution. So colloidal solution, as you know, there is the complete uniform arrangement. If we draw here, let this be the beaker, and if there is the here milk, so there is uniform composition throughout. There is uniform composition throughout. This is colloidal solution. But what about suspension? In suspension, draw other diagram. The beaker, we have water plus soil. What happens? When we mix water plus soil, the particles of soil, they will be floating throughout. The particles of the soil, they will be floating throughout due to agitation, due to apply of force. But what happens after some time? The particles of the soil, they start settling down. They start settling down, and so these are the soil particles. These are the soil particles. These are soil particles after some time. So it means the suspension is unstable. Suspension is unstable, whereas colloidal solutions are stable. We have to see some more point about these two solutions. The size, in case of two solutions, size of particles of the solute, it is less than 1 nanometer. Less than 1 nanometer. 1 nanometer 10 to the power minus 9 meter. 10 to the power minus 9 meter. 1 nanometer. Similarly, colloidal solutions, 1 nanometer to 1000 nanometer size of solid particles. In case of suspension, the size of solid particles is more than 1000 nanometer. That's why here see the particles of sand, particles of soil, they settle down in the bottom. So this is about the description of mixture and its forms.